So as we know that the first order differential equation is of this form: dy by dx is equal to f of x comma y for some function f. Okay, now in this session we will see a method to solve a differential equation, first order differential equation of one particular type. Okay, so the first method is called as variable separable method. Okay, as the term suggests, variable separable. In this, if we have a differential equation in which we can separate the variable, we can solve it using this technique. Okay, basically what does it mean by saying a variable can be separated, can be splitted, is that I can write down this function f of x comma y as a function of x independently and function of y independently. That means I can split it as a product of a function of x and function of y. So if we have a function of the form dy by dx equal to say h of x into g of y, some function of x and some function of y, then it can be very easily solved by separating the function of x along with their differential coefficient and the function of y along with the differential coefficient and then integrating it. So basically what we are doing is that I can write down this as 1 by g of y dy is equal to h of x dx. Although this is not a technical way of doing it, we can use it as a one method. Okay, so once we get this, next what we can do is that we just integrate it on both sides. So this integration is with respect to y, okay, and this integration is with respect to x plus the integral constant. Okay, and so once you integrate, you will see that you will get an expression, a functional in terms of y x independent of any differential coefficient. Okay, so that's how we solve this. Okay, you just separate the variable and integrate both the side. Let us see some example. Solve first one. Dy by dx is equal to x into 2 log x plus 1, the whole thing by sin y plus y cos y. Okay, y cos y. Now you can see that this is in the form dy by dx is equal to f of xy. This can be called as f of xy, the right hand side. Okay, now here if you observe it, then this can be written as x into 2 log of x plus 1 into 1 by sin of y plus y cos y. So this is treated as a function of x and this is treated as a function of y. So that means we can separate the variable. In this case I can write down this as, so this is my problem, I'll call this as equation 1. Okay, so this can be written as sin y plus y cos y dy is equal to x 2 log x plus 1 dx. This is dy, right? So as you can see that we have the function of y with dy and we have the function of x with dx. This dy dx has to be appeared in the numerator. Okay, so now we can integrate this. Integrating this we get integral of sin y plus y cos y dy is equal to integral of x 2 log x plus 1 dx plus the integral constant. So that is same as writing, I can split this integral of sin y dy plus integral of y cos y dy is equal to integral of 2 into x log x plus integral of x dx plus the constant. So if I integrate this further, this is same as integral of sine is same as minus cos y plus, here we used a very old fashioned technique, we use the preference I late, okay, ILATE, okay, so it's already in that form. So if I integrate this, this is same as y into integral of cos y, that is sine y, minus integral of cos y, that is sine y. This as it is, this term will come as it is, into derivative of 1, that's equal to 1 dy equal to this. Again over here you need to write down this in the prescribed form, the old fashioned technique ILATE. This is the preferred way of writing. So first we can write log x and then x as log come first. So 2 into log x into integral of x, that is x square by 2. I'll put this purposely in bracket as I have to use this term, x square by 2 integral of x by 2 into log of x, that is 1 by x dx, okay, plus you have one more term, x square by 2 plus c. This can be further this can be further simplified as minus cos y plus y sin y minus, okay, now the integral of sine is minus cos, so minus into minus plus cos y equal to, here you have a bracket 2 into x square by 2, so this 2 gets cancelled with this, into log x minus 2 into, okay, integral of this here, this is same as saying integral of x, which is same as x square by 2, so you have x square by 2, okay, right, x square by 2, this 2 gets cancelled, so you have simply x square by 2, right, x square by 2, this is, there is one more 2 plus x square by 2 plus c. So that's the expression which can be considered as the solution to the given differential equation. If I simplify this further, this and this gets cancelled, this and this gets cancelled, so we have y sin y equal x square log x plus c is the solution to the given differential equation 1. This is how we solve it, okay. Now most often this differential we may not be able to directly solve it using the separable variable technique. We might have to do some substitution to get the differential equation into the required form. For example, this, if it is already separable, we can directly integrate it and solve it. Now in this example, x raised to 4 dy by dx plus x cube y is equal to minus sec of xy. I'll call this as equation 2. Now as you can see very easily over here, it is impossible to separate the variable x and y, but it can be converted to a separable variable form by certain substitution. Now that comes through observation. Now if you see the left hand side can be written as, I can take x cube common, and so what remain inside is x dy by dx plus y is equal to minus sec of xy. Okay. Now, if I substitute, if I convert y to the new variable by the substitution, v is equal to xy. So that means I'm replacing xy by v over here. So the new dependent variable is v, and the independent variable will remain same as x. If you do this thing, you will see that this bracket will get replaced simply by dv by dx. As from here, if you see dv by dx, then it is same as, you just use the product rule, x into the derivative of y with respect to x plus 1 into derivative of 1 by x with respect to x into y. So this bracket is exactly occurring over here. So I can rewrite this as, so 3 becomes x cube. Now you have to write down this, the equation 3, only in terms of v and x. So x cube, this becomes exactly dv by dx is equal to minus sec of v. Okay, now in this case my dependent variable is v and the independent variable is x. Now you can very easily see that this is a variable separable form, as I can separate the variable. Just look at this. What I'll do is that I'll get this function of v to this dv, dx to the other side, and the function of x to the other side. So that's same as writing minus 1 by sec of v into dv is equal to, you have dx over here, this x cube, when it goes over there, it goes as 1 by x cube, right? Okay, now we can directly integrate this. So integrating this, integral of minus 1 by sec is same as cos of v dv is equal to integral of x raised to minus 3 dx plus the constant, which is same as writing integral of cos v is sine of v minus cos v is sine of v is equal to integral of x raised to minus 3 will be same as x raised to minus 3 plus 1, that is minus 2 upon minus 3 plus 1, that is minus 2 plus c. Now this is not a final expression, final solution, as we are still using the dependent variable v, so we will replace it by our original variable x and y. So that's the final solution to the differential equation 2. Let us see one more problem of similar type, wherein the substitution occurs. Cos of x plus y dy is equal to dx. Again, we cannot split this cos of x plus y, and even after splitting will not be able to separate the variable. So the best thing you can do over here is that try x plus y as a new variable, new dependent variable, which says that dv by dx is same as the derivative of x with respect to 1, that is 1 plus dy by dx. So that's your dv by dx. So that means dy by dx you will replace by dv by dx minus 1. So now the same equation can be written as, I'll write it down as dy by dx is equal to 1 upon cos of x plus y in the general form. So dy by dx is same as dv by dx minus 1 equal to 1 upon x plus y is same as v, so cos of v. Okay, now you can see that this can be separable if I write down this as dy by dx is equal to 1 plus 1 by cos v. That is actually same as saying 1 plus 1 by cos v is same as sec v. And so we have I can write down this again. This can be easily separable. So I'll get that 1 plus sec v to this dv. So 1 by 1 plus sec v into dv is equal to dx. You just need to integrate this to get the equation, get the solution. So integrating, we get integral of 1 by 1 plus sec of v dv is equal to integral of dx plus the constant c. Now this can be written as, now there are different ways to solve this. So I can write down this as 1 plus 1 by cos v. So this become inside the integral it becomes cos v upon cos v plus 1. By taking this as 1 by cos v and multiplying dividing throughout by cos v, we get this dv is equal to, this is same as x plus c. So that's same as writing, here we need to balance the term to integrate this. So what I can do is that I can write down this as cos of v plus 1 as one term and balance it by minus 1, the whole thing by cos of v plus 1 into dv equals x plus c. So that in short that becomes, if I split the term, then this is same as cos v plus 1 by cos v plus 1, that is 1 minus 1 by 1 plus cos v plus 1. So now it becomes a simpler task to integrate this x plus c. Okay, we know the integral of 1 is same as x, so this is same as x minus, we just need to integrate this 1 by 1 plus cos v this is dv is equal to x plus c. So how would we integrate this? Again, we use a basic rule over here, x minus some standard trigonometric property. We know that cos of 2a is same as 2 cos square half of this parameter, that is a, minus 1. So we are using that fact. I can write down this as cos of 2 times v by 2. So that will, in that case, my a is just v by 2, and so I have 1 upon 1 plus cos of v can be written as 2 into cos square v by 2 minus 1 dv, and the other side as it is x plus c. So that's same as writing x minus integral of 1 and 1 gets cancelled and you have cos square of v by 2 dv x plus c. Now this is the very simpler integral, x minus 1 by 2 into integral of 1 by cos is same as 6. So this becomes 6 square v by 2 dv is equal to x plus c. Integral of 6 square is same as 10 square, provided you change this v by 2 to some other parameter, and that half is actually occurring over here. So I can directly write down this as x minus. If you want, you can just do the substitution v by 2 and you will see that this is exactly same as tan of, because integral of sec square is tan, so tan of v by 2, the other side is x plus c. So that's not again complete, as I need to just again this s and s gets cancelled, so I don't have to write down this. Tan of v is same as, I can write down this v as what was the substitution, x plus y by 2 is equal to c. So this is the solution to the given ODE. Okay, so this is how we solve the differential equation using the separable variable technique. Thank you for watching this video. Okay, we will meet in the next video with some other techniques of solving the first order differential equation.